Okay, welcome back to McNab Chemistry. Today we're going to have a look at reduction of aldehydes and ketones. Okay, so firstly, let's just a quick reminder that reduction can be identified when a molecule either loses oxygen or gains hydrogen. Okay, so also remember that aldehydes are formed by the oxidation of primary alcohols. Okay, so that's in year 12, where we make aldehydes by the oxidation of primary alcohols using the distillation apparatus. Therefore, it would make sense that aldehydes can be reduced back to primary alcohols. Okay, so if I've got my aldehyde here, meth-eth, that's ethanal, with the CHO group there. You can see there by adding hydrogen, okay, we get ethanol. Okay, and you can see the difference in the molecular formulae. The ethanol here has 2 more hydrogens than the ethanal. Okay, so there we go. Okay, so it's also worth remembering then that from year 12 that ketones are formed from the oxidation of secondary alcohols. Okay, so therefore it would make sense for ketones to be able to be reduced back to secondary alcohols. Okay, so there's my ketone meth-eth prop, that's propanone. Okay, and I can reduce that back to meth-eth propan-2-ol. Okay, and you can see there from the molecular formulae that the propan-2-ol has 2 more hydrogens than the propanone. Okay, so in conclusion then, when aldehydes gain hydrogen, they become reduced back to primary alcohols, and when ketones gain hydrogen, they become reduced back to secondary alcohols. Okay, so the next question then is what reagents do we use to deliver the H required to reduce the aldehyde or the ketone? Okay, so the next question is what are the reagents that deliver the H to reduce the aldehyde or ketone? Okay, so really we've got a few options. Okay, the first one, which is always quite a good option, and we can add nickel and hydrogen gas. Okay, so the aldehyde or ketone can be passed over a finely divided nickel catalyst. Okay, so it's finely divided because that increases the surface area of the nickel catalyst. So we pass it over a finely divided nickel catalyst in the presence of hydrogen gas. Okay, so my aldehyde in the presence of hydrogen gas makes a primary alcohol. My ketone in the presence of hydrogen gas makes a secondary alcohol. Okay, another option then is to provide a hydride ion. Okay, so hydride ions, H- ions, these are probably new to us at this stage. Okay, so the hydrogen can be delivered as a hydride ion. Okay, so that's a hydrogen atom that's gained an electron, okay, to form H-. Okay, so in aqueous ethanolic conditions, the hydride ion can be delivered from sodium tetrahydridoborate 3, NaBH4. Okay, so in aqueous ethanolic conditions, if we want a hydride ion, we go to NaBH4. If we have anhydrous conditions for our reaction, the hydride ion can be delivered from lithium tetrahydridoaluminate 3, so LiAlH4. Okay, and it's also worth noting, this comes up in exams, which is your strongest reducing agent out of LiAlH4 and NaBH4. Well, LiAlH4 is a more powerful reducing agent than NaBH4. That's a good multiple choice question and worth knowing. Okay, right, so let's have a little look at the mechanism for these reactions. Okay, they're nucleophilic addition reactions. All makes complete sense. The H- behaves as a nucleophile, comes along and attacks the delta positive carbon of the C equals O group. So that's my C equals O is a carbonyl group, isn't it? So H-, my nucleophile, comes along and attacks the delta positive carbon of the C equals O group. Okay, the reason we've got a dipole across the C equals O group is that the oxygen is much more electronegative than the carbon. Okay, so we get electron drift towards the oxygen. Okay, so we've got quite a big dipole across this carbonyl group there, which means that nucleophiles can attack the delta positive carbon. Okay, so the first thing that happens then is this hydrogen, okay, it forms a coordinate bond with that carbon. So both electrons coming from the hydrogen forming a coordinate bond with that carbon, so it adds on to there, okay, hence the nucleophilic addition, okay, and then this O becomes an O minus, okay, and then the electron pair on that O can form another coordinate bond with a H plus ion, okay, and we end up with our primary alcohol. So how many H's did we need in that reaction mechanism? We needed 1, 2, so therefore 2 H's drawn like that, okay. These square brackets just show that we needed some hydrogens from somewhere, okay, and they came from a reagent, okay, but we don't want to write down what that reagent is, okay. Right, so RCHO, so that's my aldehyde, plus 2 H's goes to a primary alcohol. The next example then could be ethanal plus hydrogen going to ethanol. So here we go, meth, eth, ethanal, H minus nucleophile adding on to the carbon, okay, so there you go, H adding on to the carbon there, okay, the oxygen becoming negative and then forming a coordinate bond with the second H plus, okay, or the second H, which in this case is a H plus, okay, and then we get our primary alcohol. So that's a nucleophilic addition reaction, okay. Right, and then finally, okay, the same mechanism takes place for the nucleophilic addition reaction of H minus with a ketone, okay, so propanone plus hydrogen goes to propan-2-ol. So you identify your carbonyl group, your C equals O group there. Again, oxygen is much more electronegative than carbon, okay, so we end up with a big dipole, a permanent dipole across the C equals O bond there, so that's delta positive, that's delta negative. My nucleophile comes in here, okay, remember that can either be delivered, can't it, from NABH4 or LiAlH4. LiAlH4 if the conditions are anhydrous, but if the conditions are aqueous ethanolic, we go for NABH4, okay, to deliver the nucleophile. Okay, so there we go, H minus attacks the delta positive carbon, okay, it adds on to that carbon, it adds on to that carbon, in doing so it makes that oxygen negative, okay, it's got a lone pair on there which can form a coordinate bond with a H plus ion, okay, and we end up with propan-2-ol. Okay, so very importantly, in conclusion then, using nucleophilic addition reactions with the nucleophile H minus, the hydride ion, coming from either NABH4 if the conditions are aqueous ethanolic, or LiAlH4 if the conditions are anhydrous, aldehydes can be reduced to primary alcohols and ketones can be reduced to secondary alcohols. Okay, thank you for watching. I hope that's been helpful. Don't forget to like and subscribe and click on the bell notification to stay fully updated.